The next chapter that we deal with in physics is kinetic theory of gases and gas laws. This is a pretty simple chapter. You just need to remember the certain basics. You remember all the assumptions of kinetic theory of gases, a simple formula PV is equal to nRT, and you can solve almost all the questions using these formula. So let us start with the first question. Area of cross section of the tube is given to be 1 centimeter square. The length of the two tubes is given, and initially the tube was empty, and the pressure inside the pressure of the gas inside the tube was 80 centimeters of mercury. Now what happens is that some mercury is introduced from here, and it rises to a height of 10 centimeters in the smaller tube. What we need to find out is the height to which this mercury rises in the longer tube. So for solving this question, let us first analyze one thing, that what happens to the gas in the smaller tube. Let us write PV is equal to nRT. The temperature of the gas is fixed. For the smaller tube, the number of moles is also fixed, which was fixed initially. Whatever moles were there also exist now. Now when the mercury is inserted, what happens is that the gas already in the smaller tube gets compressed in this region. So what we can write for this gas is equal to P1 V1 is equal to P2 V2. This is also known as Boyle's law. We need not remember all these laws separately. You may remember, you just remember the names as to this is called this, but everything can be solved by using PV is equal to nRT. So we apply P1 V1 is equal to P2 V2 for the volume of gas which was in this tube initially. While applying this, we get the initial pressure was 80 centimeters of mercury. A pressure of 80 centimeters of mercury means that it is equal to the pressure of a column of mercury of height 80 centimeters. So this can always be written as density of the mercury into the G into 80. So this is the meaning of the pressure of 80 centimeters of mercury, but we do not need this now. We let it be in the terms of centimeters of mercury. This into L1, the area of cross section is A. L1 was the initial length into L1, that was equal to 50, is equal to the final pressure, let that be P1, let the pressure here be P2, is equal to P1 into the length is 10, so therefore the remaining length is 40 centimeters, 40 into A. On solving this, we get P1 is equal to 100 centimeters of mercury. Now by applying the similar equation on the second part, we get 80 into 80 was the initial pressure, P1 into V1, V1 was equal to A into L2, L2 was equal to 100, this is equal to P2 into A into, we need to find out this length L, that is the height to which this has risen. Therefore we can write the second part as 100 minus L, A gets cancelled, therefore we get 80 into 100 becomes equal to P2 into 100 minus L. This is another equation that we get. Now we have three variables P1, P2 and L, so we need another equation to solve this question. The third equation will come from the fact that we know that in a liquid pressure is always same at the same level, at the same horizontal level. So let us check this level. So pressure over here should be equal to the pressure over here, because this is a singly connected liquid. We already know that in a singly connected liquid the pressure is same at the same level. Therefore we can write another equation, that is P1 is equal to P2 plus rho mercury into G into this height, that is equal to L minus 10. This is nothing else but the height of mercury L minus 10. This is the pressure due to a height of mercury column equal to L minus 10. Therefore we can write this as P1 we already know as 100 centimeters of mercury. Therefore P2 is equal to 100 minus L minus 10 centimeters of mercury, because this pressure is L minus 10 centimeters of mercury. Therefore P2 is equal to 100 minus L minus 10 centimeters of mercury. So this is one equation we get in P2 and L. This is another equation that we get in P2 and L. So we get two equations and two variables. So on solving this, we get P2 is equal to 110 minus L. On putting this value over here, we get 80 into 100 is equal to 110 minus L into 100 minus L. So we get a quadratic equation in L, which on solving gives us the value L is equal to 15.5 centimeters. So our final answer for the length to which the mercury column has risen in the second tube comes out to be 15.5 centimeters. So the only thing you needed to keep in mind in this question is that you always remember the formula PV is equal to nRT, and whatever be the variables given, according to that you decide what is constant. Over here in this question we decided that since the temperature was constant and the number of moles in this column of gas remained constant, therefore we applied PV is equal to constant and we got P1 V1 is equal to P2 V2. Therefore in other different questions you can get different relations and accordingly you can solve the question. So final answer for this question was 15.5 centimeters.